This is Berkeley Talks, a UC Berkeley news podcast from the Office of Communications and Public Affairs that features lectures and conversations at Berkeley. You can follow Berkeley Talks wherever you listen to your podcasts. We're also on YouTube at Berkeley News. New episodes come out every other Friday. You can find all of our podcast episodes with transcripts and photos on UC Berkeley News at news.berkeley.edu/podcasts.
Good afternoon. I'm David Ackerley, Dean of Rausser College of Natural Resources, and very pleased to welcome you for the second in two lectures in this semester's Charles M. and Martha Hitchcock lecture series. The title of the series, Agency, Urgency, and Hope, Science and Scientists Serving Society. It is an honor to introduce the Honorable Jane Lubchenco, PhD, professor at Oregon State University, and a member of the Pontifical Academy of Sciences, among many other honors, many of which were mentioned yesterday, and I won't repeat them all. Jane has just returned to her academic life after 4 years in the White House, serving as Deputy Director for Climate and Environment at the Office of Science and Technology Policy. And for those who attended yesterday, you heard her give a just inspiring, hopeful talk that I think lifted a lot of our spirits about the work that was done in the last 4 years. And as she said, all the efforts that were made to make that work sticky in government as hard as possible to undo, and now we will wait and see how that unfolds, of course. Prior to her recent stint in Washington, Jane served in the first Obama administration as the head of NOAA, the National Oceanic and Atmospheric Administration, and subsequently as the U.S. Science Envoy for the Oceans. She has a distinguished career as an ocean scientist, with more than 300 publications spanning a wide range of topics in ocean science, sustainability, and science policy. From 1992 to 1993, she served as the president of the Ecological Society of America and was the lead author on a paper that many here will likely remember, the Sustainable Biosphere Initiative, that played a critical role in allowing the ecological community to really set its own agenda and define, both for federal funders, for universities, for the community as a whole, how ecology would really deeply engage with the emerging environmental challenges of our time and with our associated disciplines across academia. I don't know if I should say this because I'm not, it is a testimony to the breadth, the amount of time that Jane has been in influential positions, that when she published that paper, I was a postdoc, which is a little sobering, but more sobering in terms of how early in her career she was having so much influence. More personally, and she didn't know I was going to tell this anecdote, as an assistant professor at Stanford, I had her son, Duncan Menge, in my introductory ecology class. It's only a little intimidating when you're embarking in your career and the past president of your professional society, you're teaching their son in your course. Duncan is now a professor at Columbia. I'm here. We exchanged a nice email this morning to say hello after many years. So apparently we both survived the incident just fine. And really, despite that small intersection, I've only intersected with Jane a small number of times over the years, and there are many, many people in this room here who have known her very, very well for many years and have watched the amazing arc of her career. Today's lecture is titled Seize the Day. A new narrative for the ocean. I'm really looking forward to what Jane has to share as she maybe gets to return to her original passion for ocean research and education. And I do want to give a special call out, and this is a Berkeley call out. Today is Big Give, our funding day. If you ask a dean to do an introduction, you will get a pitch. But most importantly, we have a new center here, the Berkeley Center for Ocean Futures. Can all of the faculty who are involved in that center raise your hand? And students, anyone raise their hand? So this is this remarkable convergence of folks who've come together in the last few years. It's really wonderful to have this oceans group emerging. I do note that I see undergraduates in the front row, all the faculty in the back. Not sure what to make of that. But you can go on Big Give and contribute to BCOF, to the new center, among many other things that we're, of course, doing to support Berkeley today. So with no further ado, I'm so pleased to introduce Jane for her second lecture of this series.
Thank you, David. That was a very generous, thoughtful, personal, and fun introduction, and I appreciate it very, very much. What a pleasure it is to be here. My thanks to the selection committee for the Hitchcock Lectures. The opportunity to give 2 lectures to this community is a very special one to me, and I am grateful that all of you are here. This talk is not just for ocean people. It is a talk for all people. This is a story I'm going to tell you today about narratives. It's a story about people and science, and it's a story about hope and possibilities. So let's dive in. Narratives and maps are important to us in ways that we often don't think about. They help us think about our world and our place in it. They help us, they frame our thinking and guide our actions. And they can, without our even being aware of it, constrain our thinking or liberate and inspire us. And so I think it's important for us to think about the maps that we use and the narratives that we have about lots of things, but in this case, about the ocean. So, what do maps tell us about the ocean? If you envision a map of the globe on a flat surface, not the round globe, but a 2D surface, most of you, I think, would envision the very traditional maps that we have, the projections we're used to seeing. This particular map is a Spillhouse projection, and it tells us something very different about the ocean. You have to orient yourself. If you haven't seen this one before, it's a little disorienting. The ocean, the one ocean, it is all connected. We shouldn't be talking about oceans in the plural. We should say the ocean. There is one ocean. And yes, there are various ocean basins. We've got the Arctic Ocean Basin up here. We have the North Atlantic Ocean Basin, South Atlantic, Indian, South Pacific, North Pacific Basin. But it's one ocean. And that actually is important for us to think about. We're all connected. What happens one place in the ocean affects other places in the ocean. The ocean feeds us, it connects us, it's our past and it's our future. And how we map the ocean helps us understand how we should be thinking about the ocean. What are the narratives that we have about the ocean? What do we tell ourselves about the ocean? Well, most of you probably have a lot of ideas about the ocean, especially those of you who work in the ocean as marine biologists, or marine ecologists, or oceanographers. The ocean to many people is mysterious, it's exotic, it's bizarre, it's unknown. Life in the oceans is just incredibly diverse, not just in terms of number of species, but different types of critters. Not only animals, but plants and microbes. And they are endlessly fascinating. They're often beautiful, and they're often very bizarre. But that's not the kind of narrative I'm thinking about. The narrative that I want to focus on is a historic narrative that is framed the way people have talked about the ocean and treated the ocean for almost all of human history. The ocean, for thousands and thousands of years, was seen as so immense, so endlessly bountiful, that people thought it must be infinitely resilient and impossible to deplete or disrupt. They thought there was nothing that you could do that would affect it. You could take as much out of it as you wanted. You could put as much into it as you wanted. I remember in the 60s, people would say, dilution is the solution to pollution. Well, I can't imagine a larger area for dilution to be possible than the ocean. And so our thinking about the ocean was it didn't matter what we took out or put in. The ocean is so vast, it is simply too big to fail, is the narrative that has framed our thinking about the ocean for thousands and thousands of years. The result of that has been overfishing, use of destructive fishing gear, illegal, unregulated fishing, climate change, ocean acidification, habitat destruction, nutrient, plastic, and toxic pollution. All of those are partly a result of the fact that we thought it didn't matter what we did. Today, the ocean is depleted, it's disrupted, it's polluted, it's warmer, it's more acidic, it's deoxygenated, all of those things. And that's in stark contrast to what the ocean used to be, which was bountiful, clean, except maybe some local pollution, and very, very resilient. The folly of this too big to fail narrative is glaringly obvious. Nonetheless, this too big to fail mindset persists today, and that arrow is supposed to be to the right there, sorry about that, leading to even more intense, unsustainable uses of the ocean. So it's not just a narrative of the past, it's a narrative that persists today. And that is driven by a number of things. One is ignorance. People still think it's too big to fail. The other is the very real allure of new economic opportunities, or desperate poverty, or desperate leaders of countries who are looking for food security, job creation for people who need food, for people who need jobs. So all of those are driving this continued overuse of the ocean. It is possible to use it without using it up, but that's not what we are doing today. And these changes have consequences. They threaten the most vulnerable people, because if we lose that source of healthy seafood by overfishing, by destructive fishing, then that puts the 3 billion people that depend on seafood as a primary source of their protein at risk. It threatens the safety and security, culture, economic prosperity, and opportunity for people everywhere. And it threatens the well-being of all of the life in the ocean. So huge, huge consequences to this. To make matters worse, there's more and more that we want from the ocean. We're asking for more shipping. We're asking for more fish. We're asking for more tourism opportunities, recreation opportunities, more oil and gas and minerals. So we've got a big challenge. And as a result, this historic narrative that we had that the ocean is too big to fail has now become a very different narrative. So here's our second narrative. The ocean is massively and fatally depleted and disrupted. It's no longer too big to fail. It's now too big to fix. And that's what a lot of people think about the ocean today. You see images of just disgusting plastic pollution, bleached coral reefs, depleted fisheries, et cetera, and people say, oh my gosh, the vested interests are too powerful. The status quo has too much inertia. There are too many problems. It's just impossible to fix. And this leads to a doom and gloom attitude and lack of engagement, lack of willingness to try to do something. Now, it won't surprise you to hear me say that, in fact, that's not the right narrative. And the good news is that there is a new third narrative that is emerging. Yes, there are huge challenges. Yes, those problems that I mentioned are very real. But informed by science and indigenous knowledge, and by experiments of people around the world that are doing really interesting, very successful things, led in some cases by industry, by communities, by young people, by government leaders. Lots of different pockets of good things happening. There are solutions that exist, and we have examples of them. We don't have to sort of invent something new. There are solutions that already exist. They are just not at the scale that is needed. They're not being adopted quickly enough. They could be scaled up, but they haven't been. So we do have some solutions. We also have lots of opportunities to develop new solutions and bring new ideas to the table, use new technologies, new things that we can invent. So there's both things that we already have and know how to do, and there are new things that we need. Some of those examples of both of those are reforming fishery management so that we fish smarter, not harder. 2, we can tackle illegal, unregulated, and unreported fishing. 3, we can enable sustainable aquaculture. 4, we can create highly protected, marine protected areas and strengthen the level of protection in existing MPAs. And 5, we can realize the power of the ocean to tackle climate change and ocean acidification, not just mitigation, but also adaptation. So those are some of the things that are underway, and I want to tell you a little bit more about each of those. So reforming fisheries management to fish smarter and not harder. What does that mean? The story behind this is based on science. There has been a lot of really impressive policy reforms of fishery management. And in particular, I want to give a shout out to rights-based approaches to fishery management, which in many cases have really transformed many fisheries around the world. The science comes from some of your colleagues. Chris Costello, Steve Gaines, and John Lynham published a paper in 2008 in which they analyzed thousands of fisheries around the world and found that those that were managed with a type of rights-based fishery called an ITQ, individual transferable quotas, performed better and in fact were not on the decline compared to fisheries that were not managed with a rights-based approach, which were getting more and more and more depleted. And that made a lot of people sort of stand up and take notice. It fed directly into the fisheries reforms that were happening when I was the administrator of NOAA between 2009 and 2013. NOAA manages federal fisheries and federal waters. We were directed by Congress through legislation to end overfishing by 2011. It was a mandate. And that meant having a fishery management plan in place for every single federally managed fishery, and to have that management plan be one that had strong catch limits and accountability, so that if you overfished one year, you had to underfish the next year. And there was accountability built into the process. Doing that was a major challenge. And to be frank, despite the best of intentions, we didn't have the best track record. Always good intentions to manage fisheries sustainably. But the challenge was the economic incentives to overfish often outweighed the regulations that had been put in place. And so conservation was at loggerheads with economic opportunity. There was every incentive to cheat, every incentive to look the other way when somebody else cheated, and the situation was not particularly productive. NOAA adopted a rights-based management policy called a catch-share policy. That's the jargon for rights-based management approaches in the US. And that was applied to a number of different fisheries. The Pacific groundfish fishery is sort of the poster child for both the problems and how well this worked to turn things around. This particular fishery has about 80 different species in it, so it's managed as a stock complex. And it had been it was in trouble, So much so that in 2000, the fishery was closed and declared a federal disaster. No more fishing was allowed, despite the fact that it had been super successful and abundant, and then the bottom fell out. After the catch share management program was put in place, it did an amazing turnaround, and species recovered sometimes 30 years faster than experts thought they would. There was a significant reduction in accidental catch of the most vulnerable species by 2/3. 13 species of the groundfish were later certified by the Marine Stewardship Council, and 40 of the species of groundfish were identified by the Monterey Bay Aquarium's Seafood Watch as a best choice or good alternative. So an incredible success story, simply because fishermen were now incentivized to be good conservationists, which they would like to do anyhow. They know it's important not to overfish. But finally, the economic incentives were aligned with the conservation incentives. Short-term was aligned with the long-term. And the end result of this program has been a significant turnaround in this very, very important fishery. This adoption of catch share programs has been successful in other parts of the world, many places around the world. The one other example I'll give you is from Belize. And this is an effort that is a type of catch share program that is called a TURF, Territorial User Rights in Fisheries Program. And in Belize, the fishery this is a nearshore fishery, is threatened by serial overfishing and a lot of illegal fishing, even in no-take areas. And that became increasingly difficult for the fishermen to make a living. After the adoption of this turf fishery, the local communities, to achieve that, local communities partnered with NGOs to try out some pilots before they adopted it more broadly. And illegal fishing decreased by 60%. There was a huge increase in catch rates, and the success of those pilots led to scaling up of the program nationwide. So it really empowered fishermen to being recipients of the policy, just being told what to do, to being agents of change for the good for their fisheries. So 2 examples from a lot around the world about how fisheries can be modified so that fishermen are fishing smarter, not harder. The second example that I want to give you of things that are already in place but need to be scaled up is to combine remote sensing, AI, machine learning, transparency, and new policies to minimize illegal fishing. Illegal fishing is rampant around the world. It is very, very serious. Not so much in our own exclusive economic zone around the US, but definitely on the high seas and in lots of EEZs around the world. This is a situation where new policies, individual people, and countries have all rallied around this problem. Interpol got in the act early on and recognized illegal, unregulated, and unreporting IUU fishing as an international crime. And they started tracing illegal fishing. So that was sort of one of the first things that happened. John Kerry, who at the time was Secretary of State, Maria Damanaki, who is my equivalent for the EU, so she was the Commissioner for Fisheries and Maritime Affairs in the EU, and Maria and I worked together and said the US and the EU are going to be in lockstep. We're really going to tackle IUU fishing. John Kerry, in his role as Secretary of State, started talking a lot more about different opportunities, promoting solutions, working together, and elevating fisheries and the ocean on the international diplomacy stage, which really hadn't been done before. It was really relegated to either fishery ministers or environment ministers. And all of a sudden, especially with John Kerry's creation of the Our Ocean Conference, where presidents and prime ministers were invited to focus on the ocean, all of a sudden the ocean and IUU fishing were a topic of presidents and prime ministers. So elevating it in the international stage was important. The UN Food and Agricultural Organization, finally, after many, many years of deliberation, had an agreement, international agreement called the Port States Measures Agreement, which was critically important because countries that sign it and ratify it agree that if a vessel is found to fish illegally, they won't let it land in ports of that nation. And if it does, they can confiscate the crew and the catch. And so all of a sudden, even though the ocean is a really big place and it's hard to patrol every place, most of those boats have to come back to port. And that's where it is possible to actually do something. And so the Port State Measures Agreement was a game changer. Over time, it came into force. A number of countries have ratified it. Global Fishing Watch was also new on the scene and created a freely available, openly transparent map in near real time of all the fishing vessels that are in the ocean, where they are, what they're doing, and using AI and ML, you can look at the tracks and tell whether it's fishing or not fishing, whether it's a trawler or a purse seiner, etc. So Global Fishing Watch was really a game changer in providing information to figure out where the bad actors were and then be able to target activities and go after them. The High-Level Panel for a Sustainable Ocean Economy, also called the Ocean Panel, a group of 14 heads of state and presidents, heads of state, either presidents or prime ministers, which I'll say a little more about in a minute, decided to really make IUU an issue, and they all pledged to ratify the Port State Measures Agreement, to work together to effect the kinds of changes that are needed. More recently, John Podesta has been very concerned about this issue, a champion of solutions. And Hila Levy, who is here, was very instrumental in having a new national security memorandum issued by the president that focused on IUU and tackling IUU fishing in ways that are much stronger than had been the case before. And so over time, lots of new policies, lots of international agreements, lots of new action, lots of attention has actually helped a lot. Ian Urbina, journalist, and other journalists, has really made the connection for people between illegal fishing and slave labor and really put a spotlight on the human tragedy that is associated with the illegal fishing with forced labor. So all of this together has actually, we're not out of the woods yet, but we're in a much better place than we were when all of this started in terms of tackling IUU fishing. Third example, sustainable aquaculture, especially of low trophic level species. There has been a lot of work done on how to make aquaculture more sustainable, most recently summarized by this blue paper or white paper about the ocean, so blue paper, from the High-Level Panel for a Sustainable Ocean Economy, focused on food from the sea, and talking about how important it is from a food security standpoint, but also how using smart fishery management, combining fisheries and aquaculture. Aquaculture is a key to food security for the future. And that is actually a very complicated story, which I won't go into because there's so many different types of aquaculture. But suffice it to say that there are good practices and policies that are being increasingly adopted, although not at the scale that is needed yet. Fourth example of good things that are happening, MPAs, marine protected areas. There are thousands of them around the world. Most of them are only lightly or minimally protected. And this is an area where science has really made an incredible difference in helping us understand the different types of marine protected areas and what you can get from one that is minimally or lightly protected versus one that's highly or strongly protected. A working group at NC's, the National Center for Ecological Analysis and Synthesis, that was led by PISCO PIs, really started down this path of pulling together the science from conservation science, larval dispersal, oceanography, ecology, evolution, physiology, and really looking at the science of marine reserves in ways that really helped us understand better what we could and could not get from MPAs. What we learned from that was that MPAs that are fully protected, also called marine reserves, can absolutely protect biodiversity and habitats. There's no doubt about that. But the bounty that flourishes within those boundaries also spills out to adjacent areas and can replenish areas outside. Critically important, they protect the big individuals that are so important to the future of a population. They export larvae, and they can restore ecological balance within the protected area. Also buffer against management mistakes and uncertainties. So MPAs can do a lot that is hugely beneficial and desirable. And one of the things that I want to really shine a spotlight on is the importance of letting those fish get big, what the fishermen called boffs, big old fat female fish. Those boffs are critically important. And you see here a vermilion rockfish, one that is 14 inches, produces 150,000 young. If you let that rockfish grow to almost 24 inches, it produces 1.7 million young because the number of young produced scales by volume. And so a little bit bigger in length means lots more young, if you will. And one thing that fully protected MPAs can do is let those fish get big, and that actually is the key to both replenishing those populations, but also to the export and the spillover that happens. California took a look at some of the science of marine reserves and said, we want that. And when the Marine Life Protection Act was passed, it went through a number of incarnations. But the end result of that was, based largely on science, the creation of a network of protected areas based on the size and spacing guidelines that the scientists from this NC's working group had produced. And so California has really been in the forefront of networks of protected areas along the coast. And that has been a model for lots of other places around the world and has brought significant benefit. Following on that good work, a lot of additional new science was synthesized and analyzed and published in a big review paper in the journal Science, and developed what is called the MPA Guide, which is essentially an analysis of different types of MPAs. And the bottom line is that what you get from an MPA depends directly on the level of protection. You don't get the same benefits, all those things I just talked about, from a lightly or minimally protected area. You get them from a highly or fully protected area. And so as people are thinking about creating protected areas, focusing on the level of protection is critically important. Equally important are the enabling conditions, the social conditions that are used to create the protected area. So a lot of new science has informed management And this framing of MPAs has been adopted by the United Nations, the World Database on Protected Areas, and is used internationally now as a result of the science. Other scientists looked at this and said, MPAs can help with biodiversity. MPAs, fully protected, can also help with recharging depleted fisheries. And MPAs can protect existing stores of carbon on the seabed. And turns out there's twice as much carbon in the upper meter of the seabed as all of the carbon in soils on land. And so protecting those stores of carbon from trawling, for example, is important from a climate standpoint so that we're not releasing more carbon into the ocean and then some of that into the atmosphere. And this was a particular paper led by Enrique Sala in Nature that did a global map of hotspots that were ripe for biodiversity protection, hotspots where if you put MPAs, fully protected MPAs there, it would replenish depleted fisheries, and hotspots for carbon protection, so you can identify where those coincide. Based on a lot of this, there was increased appetite for creating an international treaty for the high seas, which have been pretty much the wild, wild west, or the wild, wild wet, areas where there's a lot of fishing, overfishing, illegal fishing underway. We now have a high seas treaty. It has not yet come into force. It has been ratified by 20 countries. It takes 60 for it to come into force. 112 countries have signed it, signaling that they intend to ratify it. And so we are moving toward, we hope, ratification of this very important high seas treaty. And then we will have a mechanism for creating protected areas on the high seas, just like countries can create protected areas in their own exclusive economic zones. The UN Ocean Conference has been an international vehicle, like the Our Ocean Conference that I mentioned earlier, to shine a spotlight and to get countries sort of competing with one another in a good way for creating, for ratifying treaties, for creating good momentum. And finally, realizing the power of the ocean to mitigate and adapt to climate change. Sorry about cutting that off on the end. And at this point, I want to tell you a little bit about a new, not new now, but new-ish group of heads of state and government, so prime ministers and presidents, called the High-Level Panel for a Sustainable Ocean Economy. There were 14 heads of state and government originally that formed this high-level panel for a sustainable ocean economy. And they pledged to work together to be leaders in the ocean space and to use science to promote the kinds of policies and practices that would turn things around in the ocean. These 14 have now become 18. That's not a lot of countries, but they collectively represent 20% of the shipping fleets, 18% of the fisheries, 42% of coastlines, and 37% of the EEZs of the world. So they actually are significant players, and what they do matters. This group of countries has promoted this triple bottom line, the 3 Ps they call it: produce sustainably, protect effectively, and prosper equitably. And so it's threefold, all of those working in concert with one another, and have committed to an agenda that is very ambitious, which goes through a number of different commitments, all based on scientific papers, blue papers, that they commissioned to inform what they should do. So it was a very unusual circumstance where heads of state and government went to scientists. I co-chaired the scientific expert group that they went to and that organized the papers, but the heads of state and government said, these are the topics we want to know about. We want to know about food from the sea. We want to know about illegal fishing. We want to know about climate change. We want to know about biodiversity. And so there was a blue paper for each of those 17 different topics that they identified, and that informed these commitments that they made, and they are in the process of moving ahead and delivering on those commitments. One of the blue papers that they asked about was focused on the ocean, and the question that they posed was, what role can the ocean play to help mitigate climate change, to reduce emissions, but also to help with adaptation? And the paper that was produced went through and analyzed the different types of ways that one might reduce emissions from shipping, from offshore wind, from blue carbon, mangroves, salt marshes, seagrass beds, ocean energy, etc., and came up with this waterfall diagram, which lists the different types of approaches that you might see and what kind of annual emission reductions you could get from each, with the bottom line being that one could, if everything went well, get as much as 20%, actually 21%, of the greenhouse gas emission reductions that are needed to meet the Paris agreements by 2050. So this actually changed the conversation about the role of the ocean. When people thought about the ocean heretofore, it had always been the ocean as a victim. And this sort of flipped it on its head and said, actually, yes, the ocean is a victim, but it's also a potential source of solutions, and really started the conversations globally about let's use not only land-based, but ocean-based opportunities. The Ocean Climate Action Plan that the US delivered in 2023 was inspired by those findings, and it was a commitment for what is the US going to do to utilize the ocean as a solution to climate change. Other actors, in addition to governments, have been critically important in this creation of a more positive, hopeful narrative. And I want to call out CEOs of major seafood companies, which might be a surprise because they haven't been the best actors. But they became very, very concerned about climate change. And they knew that that might be a threat to their business model. And they went to scientists, and scientists led by the Stockholm Resilience Center worked together to create a new organization called SeaBOS, Seafood Businesses for Ocean Stewardship. And it's a partnership between the CEOs and these scientists, where they agreed to help guide the decisions of the CEOs so that they could have more sustainable practices and policies while also focused on climate change. So it was both climate change was the initial hook for them, but then they became increasingly aware of how much overfishing was going on, which they hadn't really paid attention to, and began saying, hey, help us become more sustainable because we care about the future. That's our future. We care about it. And so these CEOs have been really committed at the CEO level to change their practices and policies. So the bottom line from a number of these examples is to recover the bounty in the ocean and then use that bounty wisely, with the idea of combination of sustainable fisheries and marine protected areas, have more fish in the ocean, more seafood on people's plates, more profitable businesses, and healthier communities. So all of those different things that I listed are actually happening. They're not at the scale that is needed. They're not at the pace of change that's needed. But they do provide examples and roadmaps for what can be done. So I think there is hope. There's new science, there's new awareness, new leadership, and new thinking. And we're bringing new technologies to bear, non-traditional partnerships, CEOs and scientists, heads of state and scientists, creating new financing, fresh champions, timely institutions. We're not where we need to be, but there is good stuff that's happening. There are hundreds of proven solutions that work. They're just not at the scale that we need for real transformation, and that is an opportunity. So this is a message, I think, of agency, getting involved in these things, of urgency because things are changing in not good ways, and of hope. And part of what I intend to do is invite you to help share some of these successes, to help replicate and scale them. And one of the lessons learned is to focus on incentives. And that means not just making people do things, not just regulations, but providing the incentives, whether they're economic incentives like catch shares or social incentives like CEOs working together and leaning on each other to effect change, or the same with CEOs. That social pressure matters. So changing incentives, providing incentives is critically important. Creating new solutions and teaming up with policy-savvy, science-respecting NGOs and businesses to really get stuff done. So I'm seeing stuff happening. This ocean that we have that connects us all, that feeds us all, is at the center of climate change solutions, health solutions, food security, recreational opportunities. And this is really all one ocean. It is possible to use it without using it up. We're not there yet, but given what I've said, it's not impossible. And I think that these findings and these actions and these results are leading to the emergence of a new narrative for the ocean. We're getting away from the ocean is too big to fix. And this new narrative is saying it's too central to our future to ignore. The ocean is not too big to fail. The ocean is not too big to fix. We have learned both of those. But it is too big and too central to our future to ignore. Thank you. I'm happy to take questions, and Jane's going to moderate. And if you have to leave, please feel free to do so.
Thank you for a very, very interesting talk. I'm Michael Weiner. I'm a climate scientist at the Lawrence Berkeley National Laboratory, and I'm working a bit on marine heat waves. And my question is, could you comment on what marine ecosystems are particularly vulnerable to the increasing frequency and severity of marine heat waves, especially those that are in the U.S. interests?
Yep. So marine heat waves, I think, were one of the big surprises. I think we just didn't really see that coming. And they have been really devastating to a lot of not only coral reefs, but a lot of fisheries around the world. And the big blob that we had off the coast of the west coast of North America really wreaked havoc on many of our fisheries. And I think there is every indication that we're going to see more and more intense and longer lasting heat waves. And that is something that we need to be, instead of being surprised by them when they happen, we need to begin anticipating that they will happen, even though we don't know exactly where and when. And so I believe that our fishery management needs to be much more anticipatory of surprises. And that's a very different mindset from the way most of our fisheries management is done, either in the US or internationally. And to pivot from reactive mode to anticipatory mode because they're going to happen. And so we need buffers for uncertainty in our fishery management as well as other practices. We also need to have better data so that we know and we understand what's happening. The NOAA has a program that is looking at sea surface temperatures in the Pacific that gives an alert to the folks in the Indo-Pacific when temperatures are increasing, and then action can be taken to try to ameliorate some of the impact on coral reef bleaching, for example. So big data programs are important there, but the anticipatory management and the realization that this is not just a one-off, that this is actually going to be happening more, is part of the different mindset that we have to take as we enter this sort of new world of surprises and changes.
Thank you so much for this presentation. It was really informative. You talked a little bit about the use of AI/ML and the role it plays in illegal fishing. So from what you said, in my understanding, the AI/ML is going to be used as a more sensory technology to sense those illegal fishing, sense it happening, to track the patterns of it happening. I'm wondering, what is the pathway between sensing that sort of activity and taking action on actually stopping it from happening? Mm-hmm. Is that a policy-related thing, like sending out people to arrest or take action on those illegal fishing activities?
Yep, good question. The use of AI/ML that I talked about that was pioneered by Global Fishing Watch was really being done way before all these new advances in AI started just sort of popping up like crazy. And so I'm sure there are all sorts of even new possibilities now. Nonetheless, being able to identify fishing vessels when they are doing illegal fishing has resulted directly in so governments, for example, that have an exclusive economic zone around them can see in near real time when the illegal fishing is happening, and then instead of trying to patrol that whole area, they can actually be much more selective and directed to going to where the illegal fishing is happening. Now, there's lots of bad actors. The story is a lot more complicated, of course, because sometimes the illegal vessels turn off their transponders. There are other ways that you can sense them with different satellites. You can see where they are and what they're doing, even if they don't have the transponders on. So it's sort of a continual cat and mouse game. But AI and ML are unleashing lots of new possibilities that are allowing enforcement, number one. And if you couple that with the Port State Measures Agreement that I talked about, those vessels when they come back to port, can then be seized. And there are a number of examples of that happening. For example, fishing illegally in Galapagos Marine Protected Area and then being confiscated when they come back into port. And there's actual evidence of what they were doing. They seized the crew, they seized the boat, they seized the catch. And so it's not like we've solved the problem, but there are many more tools available than there used to be, with more to come.
Hi there. I was wondering if you could comment on a technology known as ocean alkalinity enhancement, which has a really it's been shown both to reverse ocean acidification and remove carbon dioxide from the atmosphere. And I was wondering if you could talk specifically about ocean alkalinity enhancement and marine protected areas, since I know that alkalinity enhancement has been shown to help restore coral reefs as one example. We'd just love to hear your thoughts. I know it's kind of an emerging and contentious topic in the ocean space.
So good question. We know that it is not enough, as Phil Duffy told me over and over and over when we were in the White House Office of Science and Technology Policy. It's not enough for us to reduce emissions aggressively. We will also need to take carbon out of the atmosphere. And one of the ways that people are talking about doing that is not only CDR, carbon dioxide removal on land, but carbon dioxide removal in the ocean. And because the ocean and the land talk to one another, if you remove it from the ocean, it can remove it from the atmosphere. There are a whole series of different ways, potentially, to do that carbon dioxide removal in the ocean. Alkalinity enhancement is one of them, but not the only one. It's the one that seems to be gaining favor among a number of people. I think the bottom line is for not only ocean alkalinity, but the other approaches that we know of, is that we don't know enough yet to know if it can be done effectively and safely in terms of what impacts it has on the ecosystems. One of the reports that we issued from the federal government was an identification of the research priorities for marine CDR so that we could get the knowledge that we need. It is knowable. We just haven't made it a priority as research priorities to do what's needed either by modeling or lab work or field work to get the information to know how effective it is it durable through time, how long does it last, over what scale, and what are the impacts that it has. There's very important social considerations in this. A lot of communities have learned that, oh my gosh, something is happening off in my backyard and I don't like it because I don't know about it and I wasn't consulted. And so as these experiments are happening, it's going to be increasingly important, and this is what this report pointed out, that the experiments be done in concert with communities and affected people and with full transparency. And so there's a lot of work to be done in this space before we know enough to actually start doing anything. Yep.
So I grew up in California, and I grew up mostly underwater. I spent all of my spare time there. Since then, I've read that California has lost 90% of its kelp.
Yep.
And I wonder if there's any prospect for doing something about it, and if there is anything being done.
Yeah, kelps are not doing well. They don't do well generally in warmer water, and they don't do well when sea urchin populations explode because their predator, the sunstar Pycnopodia, died in a mass die-off of sea stars from Alaska down to Baja. This is a very grave concern because, of course, they are critically important to habitats and lots of other species along our coasts. And that's in California, it's in Oregon, it's in Washington as well. This is an area where there is active work underway to try to figure out how can we recover kelp forests, they have a complex life history. And so some scientists are looking into how can we accelerate their recovery? How can we grow the few sun stars that we know are still exist? How can we grow them in the lab and then outplant them so that they can start eating up all the sea urchins that are munching through the kelp forests, et cetera? There are also overfishing of other predators. It wasn't just die-off of the sunstar. Overfishing of sheephead, for example, which is an urchin predator. So there are a number of different interactions. I think the jury is still out. I think it's, there are people that are working on it, but I think, because the ocean continues to warm, that's going to be the biggest challenge. And so hopefully there can be all these other things come into play. There are kelps that are more warm water tolerant, And there are genotypes of the different kelps that are more warm water tolerant. So it's not clear exactly how that's going to sort out. Mm-hmm.
Hi, my name is Ria Raut. I'm a first-year PhD student in ESPM. So you mentioned that we need to give people incentives to, do things about climate change-related things. And I think incentives can come in the form of, policy or social pressure. But to get there, we need to, communicate the importance of science and of our actions. In your opinion, how do we communicate the importance of science and, convince people to fall back in love with the natural world when it seems like there's this big disconnect between people and nature, and it seems like we're in this increasingly polarized world where one side doesn't really want to hear what the other has to say? Thanks.
I love your question. Thank you. You've really, great. Really elevated the importance of people being out in nature, whether it's underwater or on land or on the water. But being in nature and giving kids opportunities to spend time in nature. But it's not just when you're growing up, it's when you're in college, getting out and having your friends get out and really be refreshed, renewed, and connect with nature is critically important. There's so much new evidence that is emerging about how important nature is to our health. Our physical health, our mental health, really amazing experiments that have blown me away about how spending time in nature changes what your brain is doing and how well you're thinking. And that's both very cool, but also somewhat surprising. So everybody needs to be out in nature more and just recognize the importance of that. And when I was at NOAA, the 4 years that I was there, super intense job, managing lots of people and politics and whatnot. And I told my team I really needed occasionally to have a break. I needed a nature fix occasionally, and I needed my family fix. And that if I was going to be sane, I had to have those. So, it was sort of, they understood, okay, now Jane needs to go diving. She needs to get out of this, Washington, get underwater, and actually have a break. And so I know that's important for me. And I think it's important for everybody to realize that and to help create opportunities for people that aren't as fortunate as we might be to actually get out in nature as well. So thank you. Last question. Taylor, you're on.
Hi, Taylor Walker, ESPM PhD student. I really appreciated your talk and your tie-in to the Spillhouse projection and your emphasis on the fact that our ocean is actually just one big, intricately tied global ocean. And I also appreciated your discussion on the utility of marine protected areas and their usefulness. However, I'm wondering, in your professional opinion, would you recommend a global marine protected area, or MPA? A lot of studies have shown that MPA effectiveness has been severely limited by staffing and funding capabilities, which is likely to vary drastically by nation. So how do we as a world try to protect our one ocean in a coordinated fashion? And do you recommend this be a one MPA or a coordinated set of MPAs? What is the solution to overcome this so that we're targeting our one ocean in a strategic way? Thank you.
Great. Thank you, Taylor. We do need lots of MPAs, not just one big one, and we need them to be in places that are supported and can do what we need them to do. The science has shown that networks of protected areas can be really helpful, but they have to be designed in ways for species to either larvae or juveniles or adults to get from one piece of an MPA to another piece in the network. We also know that really, really big MPAs, which we have, for example, around Papahanaumokuakea in the Northwest Hawaiian Islands, or the Pacific Heritage Islands is the new name now, in the Indo-Pacific. And those really, really big ones, or the Northeast Canyons and Seamounts in the North Atlantic off Cape Cod, those areas that are really, really big are critically important to migratory species as well as the species that are actually resident in there. And so there's not a one-size-fits-all. We need small ones, medium, large ones. We need networks. We just need more of them, and we need them to be more protected and more and well enforced, well supported, and well resourced. And that's a challenge. But when you have ones that are performing and doing well, that actually is triggers doing more of them. And so part of the getting the word out is sharing what happens when you have successes. And that's what has happened through our ocean conferences, and in particular, is not only presidents or prime ministers, but communities coming together and say, hey, this is what we did, and whoa, look at what is happening. And that actually inspires others to do more. So it's both a combination of science, but also community experiences, community supported. And there's a big movement for a lot of community-driven MPAs. So I think we know we have the lessons learned. We're going to cut it off, sorry. We have the lessons learned, and we know about those things are important. That's part of what's highlighted in the MPA guide, which was, again, in Science of 2021. But we don't have them at scale. And so the 30 by 30 is not just about quantitative, it needs to be qualitative. And the quality of the MPAs and whether they're resourced and supported is critically important. So thank you all very much. Dave's going to cut us off here.
Two quick things. First, thank you all for coming, both yesterday and today. Second, please join me first to thank Jane Fink, whose excellent organization supported these events. And you will see the doors are open. We have a reception, and you are all invited to a reception afterwards to speak more with Jane and with each other. And finally, join me one more time in thanking Jane for the lecture.
Thank you.
You've been listening to Berkeley Talks, a UC Berkeley News podcast from the Office of Communications and Public Affairs that features lectures and conversations at Berkeley. Follow us wherever you listen to your podcasts. You can find all of our podcast episodes with transcripts and photos on UC Berkeley News at news.berkeley.edu/podcasts.